Hello students, welcome back to my YouTube channel Mathematical Lens by Namita. In this video, we are going to continue with chapter number 2, Lines and Angles of grade 6, Ganitha Prakash, the new NCERT textbook. So let us discuss the figure it out exercise given on page number 40, 41 and 42. I'm going to teach you how to measure angles. Here the question is find the degree measures of the following angles using protractor. So just see how to do it. So first what we do is we match the baseline with one of the rays, the baseline, and the center with the vertex, right? That should overlap. First you need to make sure that. And now just see this ray is our baseline. So we'll start from 0, right? So see the inner scale. In this case, if you see the outer scale, it will be wrong. And now just see here, where is the other ray? So it is at 48 degree. So you can write measure angle IHJ is equal to 48 degree. What is important over here is the vertex should be in the center while writing the name of the angle 48 and the degree symbol, right? Now I'll show you the second one. Let us see. So again, just take care of the baseline and the center. And here, this is exactly between 20 and 30. So this is 25 degree. The name is same, so I'm not writing that. Now, in this case, you can take the support of the hand because the book, it is difficult to fold. Right? Then you may not get exact measurement if you fold it. Then just see it is exactly 110 degree. So question 1, that is. Now question 2 is find the degree measure of different angles in your classroom using the protractor. So try it yourself the way I have explained and take care of the important points which I just told you. Question number 3. Just keep the center and the vertex intact. Overlap the baseline and you can see this is the 0 and this is 40 degrees. So this measure is exactly 40 degree. Now let us see the other one. You can take any one of them as a baseline, okay? Not necessary whatever I'm doing, just take care of the vertex, the baseline, and here you can see that it is between 110 and 120, so it is 115 degree. Like suppose if I'll show you, if I take this as a baseline, the other side, you can do that also. But here, now see, you will get exactly the same answer, right? 115. But here you need to see the outer scale. Otherwise, any one of the ray can be a baseline. Now, question number 4. Again, you have to find out the degree measure using the protractor. So we will see here. It is exactly 100 degree. Question number 5. Measure and write the degree measures of each of the following. All are similar type of questions. So you can just measure. This is exactly 80 degree. I think now you have understood the method, so we can do it a little faster. So this is, you can just see the baseline and the vertex. It is 120 degrees, right? Question 5C. This is 60 degree. D. Now you can see here the angle is facing on my left. right? So this is 130 degree. Now here you can keep this as a base. So I'm keeping this as a base. So I'm seeing the outer scale. So this is also 130 degree, right? They have given different orientations of the same angle, right? So that you understand the types of angles by just looking at them, right? So now question 5F, this is exactly 60 degree, okay? Question number 6, find the degree measures of angle BX, BXE, CXE, AXB, and BXC, right? So we'll first find out BX, BXE. Now here there is a baseline, so we see the inner scale, and here you can directly write it as 115. So measure angle BXE is equal to 115 degree. That's easy, okay? Then CXE, CXE. Here also there is a baseline which is aligning with the baseline of the protractor. So we start from 0, and here you can see it is between 80 and 90. So measure angle CXE is equal to 85 degree, correct? Now AXB. AXB, you can see, we'll have to see the outer scale because the baseline is on the left hand side. And if we see the outer scale, it is exactly between 60 and 70. So measure angle AXB is equal to 65 degrees. So the last question which is asked is BXC. So what you can do here, the simple way will be you can count by 10, 10, right? So this is like at 5. So from here to the middle of 70 and 80, it is 10. This is 110, this is another 10, and this is the third 10, right? So measure angle BXC is equal to 30 degree, right? Or you can find out AXC, which is 95, minus AXB, which is 65. So 95 minus 65 is 30 degree. So there are many ways of getting this particular angle, right? Now, number 7, find the degree measure of angle PQR, PQS, and PQT. Here, the baseline, if you can see, it is same in all, BQ. So, you can actually read all of them together and find out the measure of all of them together. Like you can see PQR, which is, we take the outer scale, so which is between 40 and 50, so it is 45 degree, right? And then we see the other one. So this is 80 degree. PQS is 80 degree. And the third one, PQT, is 150 degree, right? So taking one baseline, you can write down the measure of all three of them. So measure angle PQR, we saw it is 45 degree. Then measure angle PQS is equal to 80 degree. And measure angle PQT is equal to 150 degrees. So we took this as a baseline and we found out all three angles because one ray was common. Okay. Now let us try to make this paper craft as per the instruction given below. So we need a square sheet, right? So like this, I have taken a square sheet. So first step is fold it. So you get two triangles. So fold it and you get two triangles like this. Then it is again folded from bottom. So this is the way it is folded, right? Then fold it again from both the sides so that you get a sort of square from the center. So this is one fold, this is the other fold. So you will get a shape like this. Now turn it. Turn it, and then from below you can just fold it, and you can just see the creases are made and there are angles formed over here. So you can find out different angles here. You can see an obtuse angle being formed. Okay. So it is like a fun activity and you will learn different angles from this activity, right? So can you see, you can make eyes and nose of the bunny, right? And just you can identify the angles which are formed here. One angle is formed here, another like that. Here it's a right angle, you can say. Okay. So this is a nice way of understanding angles. Measure all the three angles of the triangle shown in this the figure which is given below. Write the measures down near the respective angles. Now add up all the three measures. What do you get? Do the same for the triangles in figure 2.21b and c. So let us try first find out the three angles of each triangle, because you would wonder how to measure all the three angles in a triangle. You have till now learned only to find out one angle where an angle is given. Here it's a triangle and there are three angles given, right? So here again, if you are measuring angle A, so this AB will be your baseline. Okay. Here in the textbook there is some overlapping two lines, so we have to be a little careful. So this is angle A, you can say this is 45 degree. Okay. Now if you want to measure angle B, I'm just keeping my hand below it so that I can overlap the baseline with the ray. So this you can see here, I'll have to see the outer scale, and this is between 60 and 70 exactly. So this is 65 degree. And the third angle we'll measure from C, and we keep C as the vertex and the baseline. Now we are considering this as a baseline, so inner angle you can see it is 70 degree. First we'll measure all the angles of the triangle and then we conclude what are we getting. Let us measure the angles given in the other triangle. The name of the triangle is all again triangle ABC. You can see angle C is 60 degree. Again this is 60 degree, B is also 60 degree. And if I keep it here and measure the third angle, that is also 60 degree, right? Now let us see the angles in the third triangle. Find out all the angles in the third triangle. So you can see the first angle, that is angle C, is 100 degree. This is where we see the outer scale. So this is 50 degree. And here, this is 30 degree. Now what is important? Let us find the sum of all of this. So if we add 70 plus 45 plus 65, this is 45 plus 65 is 110 plus 70. So the total is 180 degree. Let us see the other triangle. 60 plus 60 plus 60. Here also the sum is 180 degree. And here it is 100 plus 50 plus 30. So here also the sum is 180. So what do we conclude from this? That sum of all the angles in a triangle is always 180. This is an important property of triangle, which we found out. Okay. Mind the mistake and mend the mistake. Here, a student has used a protractor to measure the angles as shown below in each of the figure. We need to identify incorrect usages of the protractor in all of them and identify and also discuss how the reading could have been made or how it could have been corrected. So let us see the first one. Here the child is saying 35. You can see the baseline. Here it's the red line, the baseline. It is not overlapping the baseline of your protractor. So that is a mistake which is done over here. If you see the second figure, again, this was in the first figure, the baseline is one of the rays outside the protractor. In the second one, though it is inside the protractor, it is starting from 10, right? So it is not starting from 0. This baseline 0, it should start from 0. Uh, so here the answer is given as 80 degree and actually it should be 70 degree. You can say the answer, the angle in between, if it is kept, if both the rays are inside the protractor, still you can answer the angle. So, but you'll have to subtract. So here it is 80 degree, here it is 10 degree. So 80 minus 10 is 70 degree. So the actual measure of the angle is 70 degree, which is written 80 degree over here. Now let us see the third, this one, angle W is 70 degree, it is given. But here, this vertex is outside the protractor and it is just in a different orientation. So we need to change the orientation and keep the vertex here. Okay. So this is the mistake. The third one. Let us see the fourth one. Now fourth one, if you see, it is the baseline is overlapping the baseline, so that's okay. But here the vertex is not overlapping the center of the protractor. Also, the angle is written as 150 degree. So if you bring this vertex here at the center, then also you will have to see the outer scale. So two mistakes they have done. The vertex is not overlapping the center of the protractor and the wrong scale, that is inner scale the child has seen, not the outer scale. So again, this angle is wrong. Now let us see the fifth question. So here, again, the vertex is not at the center. We need to pull it down here. And one of these rays should match with the baseline. Yeah, correct? So this is again wrong. Now if we go to the last question which is given over here, here you can see the vertex is overlapping the center of your protractor. The baseline is also matching, so that way it is correct. But here the angle is written as 85 degree. Now you see the baseline. Where is the 0? 0 is on the outer circle. So you need to see the outer measurement. So it is between 100 and 110. So it should be 105 degree instead of 85 degree, right? So the child has seen the wrong circle. Okay, so these are the things which you need to take care while measuring any angle. So mind the mistake and mend your mistake. So you have to be careful in all these ways. Otherwise, it's very easy to measure angles with the use of a protractor, right? Now let us try to solve the figure it out questions based on the angle and the clock, how the clock is related to angle, right? So here there are some questions asked. Where are the angles in a clock? Now just see the first one. The hands of a clock, they make different angles at different times. At 1 o'clock, the angle between the hands is 30 degree. Now why it is 30 degree? It is asked why. So just see, this is a full circle. Full turn, we have learned it is 360 degree. And there are 12 numbers, 1 to 12. So if we divide 360 by 12, what we will get is 12 3s are 36, so you get 30 degree. So this is very important. If you remember this, that the angle between any two numbers, like between 12 and 1, when it is exactly 1 o'clock, it is 30 degree. Okay? So then it is easy for you to answer all other o'clocks, right? So now they have asked what will be the angle at 2 o'clock. So 2 o'clock you can see this is 30, 12 to 1 and 1 to 2 is again 30. So it is 60 degree. Now if you see 4 o'clock, so 30, 30, 30, 30. So it is 120 degree, right? And 6 o'clock, the hands will be here. So you can even see the semicircle, the half turn, so it is 180 degree, right? So we'll write the answers over here. So for 4 o'clock, it is, sorry, first is 2 o'clock. So 2 o'clock, the answer is 60 degree. Then for 4 o'clock, it is 120 degree. Now you can do it mentally. Once you learn this 30 degree, all the o'clocks the answer can be given directly. So like this is 30. So 31s are 30. This is 4. So 30 into 4 will be 120. This is 2. So 30 into 2 will be 60. Then they have also given 6. They have also asked 6 o'clock. So it is 30 into 6, 3 6 are 18. So it is 180. Right? So this is how you can do it mentally for all the o'clocks. So explore other angles made by the hands of the clock. Like suppose if it is 7 o'clock. Now we are considering this clockwise direction. So again the trick which I told you, 7 into 3, 7 3 are 21. So the degree will be 210 degree. If it is 7 o'clock, we have considered it as 7 o'clock. Let me write down that so it's easy for you to remember. O'clock. This example, one example we have taken. You can take more examples like this. So it is 210 degrees at 7 o'clock. Okay. Now, that's what I told you, that 7 o'clock we are considering the clockwise, that is the reflex angle. It becomes a reflex angle. Suppose in exam or anywhere else, if it is marked, the angle which is marked inside at 7 o'clock, then the answer will be different. So what you can do, you can find out 210 and subtract from 360. Right? So in this, like 2 o'clock, suppose we consider. So we are considering the acute angle. And if the obtuse, this is marked, the reflex is marked, sorry, the reflex angle is marked, then the 60 you will subtract from 300. So that would be 300 minus 60. This I am talking about, this is asked, inside it is marked, it is 60 degree. Okay, but if it is marked outside, this is asked, this, so 300 minus 360 minus 60 will be 300 degree. So that care you need to take where the angle is marked. So right now we are just considering the clockwise direction, clockwise movement of the hands of the clock. Now there are some more questions based on the angle and the clock. The angle of a door. Now they have asked an angle of the door. Is it possible to express the amount by which a door is opened using an angle? What will be the vertex of the angle and what will be the arms, right? So you can see the vertex, here there is a hinge, the door hinge. You can see this is the vertex. Here is the vertex and these are two arms. This is one arm and this can be considered as another arm. So this would be the angle form, right? So we can understand the angle. You can mark the angle over here. You can show the arms and the vertex. Please use scale to do so. Now here Vidya is enjoying her time on the swing and she notices the greater the angle with which she starts the swinging, the greater is the speed she achieves her swing. So where is the angle form? You can see these are the two arms, the branch and this rope. So there is an angle formed between the branch and the rope. So this is the angle. So greater this angle is, the greater will be the speed. This you might have experienced when you yourself are swinging. Question number 4. So here is a toy with slanting slabs attached to its sides. Right? You can see the slabs. The faster the ball, so the greater the angle or the slope, the faster the ball rolls. So can the angle be used to describe the slope of the slabs? And what are the arms of each angle? which arms are visible and which are not. So you can see here there is an angle formed over here. There is an angle formed over here with this. Another angle is formed here. So yes, you can the mark the arms in each of this case, like this border can be considered as one of the arm. In this angle, you can consider this as one of the arm and the other arm, and the angle is formed. So yes, it is possible. Some arms are visible and some are not. So what you'll write here? Yes, it is possible. Observe the images. Now here there is an insect and its rotated version, right? So can the angles be used to describe the amount of rotation? How and what will be the arms of that? So you need to identify. Now here you can see the horizontal line which is touching. So this can be considered as your baseline and this is almost straight. So you can see that a 90-degree angle is formed here. Okay. Similarly, this was about the snail and this is another insect that is beetle. So here also almost 90-degree angle is formed. So this is the baseline, this is one of the arm and this is another arm can be imagined over here. In this snail's case, this can be one of the arm and the baseline which you can see. Right? So this is how you can identify angles in nature, in your surroundings, right? And relate maths with real life. We'll continue with this chapter in the next video. Thank you.